Okay, let's talk about the problem in the week 7 assignment. And I was asking you to calculate the net, cut, and or fill, whatever it turns out to be, for this grade plan that I've gone over. And I first got kind of caught off guard. There's one student uh, didn't know what video I was talking about when I referred to the video. And I think I refer to it. Yeah, I said using the grade plan below. This is the problem itself. Calculate the net cutter field for quadrant CE 57, and note that this is the same as the yellow quadrant. And I'll just go ahead, and this is going to be some back and forth. Here we go. Uh, Here, and it'll come up again with a lot more information. And it's alarming that some of you couldn't find the video. It had exclamations marks beside it. It said cut and fill analysis. I didn't know what else to do. But we're going to kind of go through what I went through on the video, and perhaps you'll begin to see the correlation between the problem and the thing and the stuff, let's call it, that was talked about in the video. So this up here uh, in the yellow quadrant talked about is in this illustration here, and it's also in other illustrations here. Now, I don't think you can read these. If you can, great. If you can't, I will explain it to you. Actually, in this figure 9, which these page 16s and 14s and 15s and things were to keep me lined up with where this information came from. These are mostly screenshots that I took from an existing course that's no longer being used by this organization, yet it's protected. So I literally snagged them because it would take too long for me to draw this. So that's the yellow quadrant that was referred to up here. And notice I said quadrant CE. We're back looking at the, you know what, let me stop, because there was a thing here where one of you guys said something about add up all the existing grades. Well, all of the existing grades. Now, there were grades that are existing later on that are proposed grades that aren't yet there. And I'm hoping that we understand the difference. But if not, I want to clarify that I can't move this around too much because it's the whole canvas thing, or I don't know how to move it around a whole lot, but I can move this around. If we go all the way back to the very first slide in the video, which is in the module again, and this is where we started. These are this is an example. The whole thing is an example, but it's the same example. We just did different things with it. The example of existing conditions, I put parentheses, contours, existing contours. What that means is the way it is before you do anything to it. This is a future site plan. This is the topographic survey, if you will, also known as a grade plan, if you will. So these are existing grades. That's the way the way the site is before anything is done to it. Now we can move around here, and as you will see, this is the existing grades are still here, right? Dashes, as well as over here. And if you look closely, or not closely even, you can see that this picture is the same as this picture. This picture is a little smaller than this picture. okay? But that's okay. Every single picture has an explanation of what it is. Like, I know you may not be able to read this, but every one of them has NTS at the end. That means not to scale. So nothing on here is to scale. And that means that when we interpolated, we were guesstimating. We were making as close a guess as we could to what elevation it was when your corners, uh, this is going to be a little crowded over here, when your grid corners right here, this maybe you can see these are grid. When your grid corners, like here, this is a node, this is a node, this is a node, and this is a node. Over here, I described, and perhaps I needed to consider that I was jumping ahead of explaining myself because one person was a little confused by the size of the grids. We don't care about the size of the grids on here. What we do care is about the quadrants because that's what I'm talking about. Now, a quadrant consists of four, what I'm going to call grids. Look at this one right here. CE, and look over here. Here is C, and here is E. So I'm defining this line here, but I'm defining it over here, but it's going to clarify itself in just a second when I say 5, 7 up here in the right, the quadrant CE 5, 7. So CE 5, 7. That is this quadrant right here. Over here, uh, it's this guy, and over here it would be defined as BC 3, 4. This quadrant right in here, BC 3, 4. So this is the same as this. Now, if I say these grids are 200 feet in length, you just got to accept that because that's what I'm saying it is. And it doesn't matter that these, I said grids, quadrants are 200 feet. Let's keep those separated for now because all of this is a grid, but this is the quadrant right here, CE 5, 7. And notice that our little nodes, like this node, for instance, this node right here is node E4. You see this? E4. The nodes are what's important here. This corner is node E6. Okay, let's go back over here because this is what's soon going to be yellow. Well, there it is in yellow, but let's keep it a little bit bigger. So this is the one we're talking about. Look what it is. This is, I don't know what they're calling it, but I would call it, if I'm talking about this quadrant right here, I would call it BC 3, 4. And I think that's what it says, maybe not here, but it may say in my notes. It does not. There, no, BC 3, 4, there it is. So that's BC 3, 4. Over here, the same place is called CE 5, 7. But note, everything is relative. See this 108 little mound here, right here? That's 108 feet. This is a completed contour line, that means it's a hill, mound, depression, whatever. But look, relatively speaking, it's pretty much in the same place. You see how that is? It's just this drawing is bigger, and it makes it look like the grids are different. Also, these quadrants, if this was a quadrant, I could call it a quadrant, but I'm not. I'm calling this the quadrant. Over here, I have more grid lines. Not for any reason, it's just what I found in this lesson to the left. I found this without any information, so I said, hey, this will make a good problem. So what we have here is what we have here. It's just a little bit, it looks a little different. These quadrants each have 4 grids in them. This quadrant has no grids in it, but it's the same quadrant as this quadrant, okay? And that's why I dropped this little hint. It said, wouldn't surprise me if there was a table nearby that yellow quadrant. Well, if we meander around here, there's that yellow quadrant, and look here, there's a table. And I just threw that in there to help you out a little bit. So what we got to do, I saw people averaging. I mean, one of the comments I saw is I added up all of these existing elevations. Well, I'm not sure that they were clear that what we were going to end up adding up was the differences at each node between the existing and the proposed grades. That's what we were going to average. And that average would be our cut or our fill. That's what this whole thing is about. Now, we'll get a little bit deeper here in just a minute. So let's be sure we know what a node is. That's the corner of a quadrant. Not necessarily the corner of a grid, but the corner of a quadrant that I have defined. And here I defined it down here in my table. Again, in my table. And these are all the nodes. And while we're here, I don't know if you can see these, but let's look. I decide averaging the proposed grades of these nodes. So that's what I did here. B3, the proposed grade of B3. Let's see if we can find it. Oh, I don't have any letters here. B3. They're talking about that proposed grade. Now flip up here, and that would be B3. Okay, back down here, up here, down here, down here, down here. It says that B3 is 103.95. Let's go back to this quadrant CE over here and look at the same node if we can. Remember, this is what we defined right here. So let me see. Oh, there it is. This is what we defined as our quadrant, I believe, right here. So look at this C5 quadrant. That is the same as this B3 quadrant right here. That is the same. And I was giving you the answers is what I was doing. And this at node B3, the existing grade is 103.95. The proposed grade is 106.25. And I was trying to get you to interpolate. They're saying 103.95 for this is the same one they're talking about right here. To us, it's C5. 5, but 103.95 is what they're saying it is. Let's find, this is really a tough one. This is a 103. Now we're looking at an existing grade, so we have to compare existing grade to existing grade. So look at what they did. They just said 103.95. Well, they're just saying it is not 104, right? They're saying that this node is just almost 104. So they're saying 103.95. And trust me, that's probably a guess. Now, interpolating will come along later on when we get into the estimating course. When you actually take and build your own scale and interpolate these things that lie between contours, like this guy right here, he's almost halfway between 107 and 106. So he's probably 106. This guy is probably 106 over 0.5, probably 106.55 is, and they may say 106.5. They may, this right here, I said 5.5. That's C4. So let's see what this is. So C4 is, I think that's B3. Give me a minute. C3, B4. B4, they're actually over here. It is the same, 103, basically, that's what I'd call it. It's almost 104, but it's basically the same. This is our yellow line, by the way, our yellow square or quadrant. So that's what you're doing. You're interpolating these things. And all of the information you needed to solve this was here. Let's keep going a little bit over here on the left. I feel like it's going to take more than even this video, and we can do, if you guys want to request one, that's not a formal thing, just give me a call or an email or something, say, can we have that you'd like to be in a big button, big canvas, big blue button, so we could talk back and forth. This is all one-way information. Look at, let's do some more interpolating. 107 is probably a pad site. I'm just guessing. They're going to take dirt and they're going to move it this way, fill in this. This may be an entryway. I would suggest this is probably going to be a parking lot. And those are guesses. Nothing says that, This is probably going to be our way in to start work just because of the elevations. Maybe we can find a way in from over here. But each of these are going up a foot. So let's interpolate. I'm back on the problem now. And remember, this is our quadrant as defined above. So let's say I'm looking at this quadrant. Remember, this is I'm looking at this node. This is our quadrant here. I want to use, let's see if we can find one. Hold on a minute. That would be such a good illustration. But let's use this one. Sorry. Right here. Let's use this one. And I have my reasons for doing that. Because I'm staying within the same quadrant, and I don't want to shift quadrants on you because this quadrant and this quadrant are basically in the same place. If you were looking at this, and you can see that this is 107, this is 106, so we're way over here, almost 106.75, 106. I'm existing grade stuff now, so I'm in this column over here. So see 106.8, yeah, that I could live with 106.8 for that elevation, because 106.5 would be about right here, 7 would be here, and it's not 107 yet, so 106.8, why not? You know, and that's what they said, 106 106.80. Is that what I've been saying? 106.80, not 18. It feels like I said that. So there that's interpolate. If we want to find, let me find another one. That's similar. Let's go with this is node C3 to them, and see where it is up here close to the 107 grade. That would be the same as this one, which is E5 for us. That's what we would say. So let's just think for a minute before we say anything. Let's decide what proposed grade is right here. So we would interpolate halfway between these two 107s, would put us basically right here. So that would be 106. Can we say 106.5? Up here is, where was I? This is oh no, 107. I'm doing proposed grades. Keep me straight, guys. So halfway between would be 106.5, which would be somewhere in here. But up here at this node, we're like 106.9, or we're almost 107. You know, we could almost get by with saying we are 107. And their C3 over here is our E5 here. So there's nothing wrong with that. There's the 107. There's the, and so we're almost, so we could call that node 107, right? So I'm not going to keep on this interpolating stuff. The information throughout this course is here, except for this. And now you should have all the hints you need, because I don't care if you use these. I'm going to move on, leaving the problem here, leaving it up, because I want to show you a little bit more of, and I don't know if it's going to be big enough or not. I would like to have not put this in here. Really don't even want to talk about this, but it's the area that they're using here. These are 200 foot by 200 foot. So you see that little difference right there? That is that difference. That is that, what am I trying to say here? That is the average of existing minus proposed. Existing, and we'll do that in a minute. Here's your average existing grade, which is in this color. Your average existing grade to them is 427.75. I'm sorry. The average is 10. I'm going to have to get a micro, what do you call it? Magnifying. Oh, my glasses would help. But it's 106. Well, I can't read it. 106.375, and this is 104.51. So this is 106.37. This is 105.5. So if I took the existing grade and subtracted the proposed grade from it, I would get, let's see if I can find a bigger, clearer table that has the same info on it. Bear with me a minute. Here we go. Now, I can read these for sure. The average right here is 106.80. the average proposed grade here is, I'm sorry, I'm telling you, this is a different method. This is the node method, node elevation differences. All the nodes are here. And this is kind of what you're doing, really, as opposed to this form. See, they're getting all of this added up, and they're coming up with an average elevation for existing and an average elevation for proposed. And really, we're kind of doing the same. Where did I lose? Here. They're doing it node by node instead of averaging first. And this is kind of the way I like to do it. And let me throw this in. If you want to know whether or not you have a cut or a fill, you can obviously look at elevations and say, look at this elevation, look at this elevation. This is existing, this is proposed, right? So it's obviously going to be a fill just by looking at it, because it's 104 or 103.95 here, it's 106.25 here, so you're going to have to fill it. Now, what they've done to get this positive number is they have subtracted proposed grade minus existing, and it gave them a positive number here. Now look at this. Proposed grade minus existing gives them a negative fill or cut here. Now, if you wanted this rule of thumb, and you will have to when we get into estimating, negative values will always be fills. Positive values will always be cuts. So this right here is not a fill, even though it's negative. It is a cut. As you can clearly see, it's too high. They're going to have to cut it from 109 to 106. Now, here's my rule of thumb. I don't know if this is written down anywhere or if it's just I've been lucky all my life. But if you, the book said subtract existing from proposed. If you subtract proposed from existing, your sign is going to tell you if it's a cut or a fill. So 103.95 minus 106.25 is not a positive 2.30. It is a negative 2.30, and consequently, it is a fill, as we can see. So that's my advice if you want to know for sure. Not saying that the difference is going to change, but the cut and fill will change relative to what it's supposed to be. But let's look at this now. We have the differences regardless of the negatives and positive. The other, but because we did on each one of these proposed minus existing, they did it. These are not going to. That's not going to be a cut. It's positive, but it's not. That's not going to be a fill. It's negative, but look over here. It's got to be a cut from existing to this. So anyway, if you don't know how to, if you may have problems averaging positive and negative values. Now, I do. As a matter of fact, I hadn't done one of these in a long time, so my biggest issue when I was getting ready to present this to you guys was I was having a heck of a time remembering how to add positive and negative numbers, because when you're averaging something, all of these will be added, even though some of them are negative. So if you have a calculator like mine, which I kind of reference or suggested you get, some of you don't have the problems I have with negative and positive, so maybe you don't need it. But every time you enter a number like 2.30, See, we got to add all these. So with my little TI-30X2S, whatever, solar it means, I guess. But if I enter the number 2.30, my next entry would be add, and that's the plus sign, but there is a minus key here. It's called the negative key, and it's at the bottom right. So you don't hit plus minus, you hit plus the negative 2.75. And then you see you got to add the negative minus 0.25. So I hit plus negative 0.25. And my total, I hit the equal sign, is negative 1.7. That is the total value of these 1, 2, 3, 4 nodes. Some are negative, some are minus. But the total value is a negative. That means even though, look, right here is the key. They changed it to what it's supposed to be. See their negative floating around here? They're calling it, I don't know if they're calling it a cut or not, but it's a fill because it's come up with, this is your net cubic yards, and you're going to have more dirt than you need. So this would be called a waste, and that's not a good name. You'd be using that dirt to balance your low spots. So it's not like you got to throw away. If you come up with a positive number, you've gotta, that's a cut, so you would need to haul some dirt in. If you end up with a fill, you don't need to borrow. If you end up with a positive net cubic, whatever, cubic yard, you're gonna end up with needing to bring that amount of dirt in. So you take your node, and I always take the existing grade of that node and I subtract the proposed grade from it, and that is my elevation difference. There's nothing wrong with this number. It's just a fill. And and it says right here in, let's see, what is the calculated net earthwork requirement for the quadrant, wherever it was, that has an average change in elevation? This is your average change in elevation. So that's found by adding these and dividing by 4, you get minus 0.425. So when you take the area back over, let's go back over here to the problem. If this is 200 feet, I think one of our students went ahead and used 400 feet. I don't care. That's not what I was looking for. But you know what? That's not what counts here. He knew that he had to find the average of this quadrant and multiply it by this average change in elevation, which was arrived at by taking the differences in each node between existing and proposed grade, add them up, divide them by the number of nodes, and that's your your difference, your average difference. I can't talk here. That's how much change is going to be between average existing and average proposed grade. So that's going to be your depth. So you have width in your quadrant. I'm back over here on our problem now. Your width is from E5 to E7. E5 to E7, and your length or height is from E7 to C7, C7 to E7. So that's length times width. That gives you your area. Now you need to, now you need your depth, which is 0.425. 200, let's use mine because that's what they did. 200 times 200 multiplied by 0.425 is 1,700. So you've got 1,700 minus 1,700 cubic feet. You take that, divide it by 27, you have minus 629 excess cubic yards. Now listen, I could go over this 1,000 times. Oh yeah, by the way, the last slide on the, slide 15, which is called page 21, has a ton of information on it. And I did this little table over here. I guess I used the values they use. You can't read these, but you can read that table right there. If you know how to interpolate, or basically how to interpolate, and you know that what we're trying to do is find the average difference between existing and proposed grade, and you know how to do that, and you know that once we have that information, all we're doing is a volume calculation, length times width to get the area times depth to get the volume. That's all this is about. And that's what we'll be doing in estimating. This is a takeoff. This is old school stuff. But, you know, the problem that when we hire, not we, but contractors hire people out of college with a degree in construction management. They know how, they can teach them how to use the software, which you will have some really high dollar software that we're getting from a company called HCSS Heavy Bid. If you want to take a look at that, you can go to that website. That'll be our cost estimating software. And we're using not a startup company. They've been around a while, but not forever. It's called Trackware or Earthworks, and that's who's going to furnish our takeoff software. So we'll have takeoff software to help us get our quantities from PDFs. The takeoff software will read the PDF that we get, and it'll tell us basically how much earth, it'll tell us what we just figured out here. You know, that we have 630 something cubic yards of earth left over. It'll tell us this. But here's the thing. These guys that come out with a degree in construction management, they don't know where that information or how that information was arrived at because the software tells them. So they, without that kind of background, it's just like your background in grades will help you when you start using automated grade control. You know what things are supposed to look like, and if there's garbage into that digital terrain model, there's going to be garbage out, and you're going to see that it needs to that you need to make a change, that something's not right. So that's the value in going through these old school methods. So when you get into the estimating course, the first thing you're going to do is probably some of this stuff, and you're going to look maybe a brief look at a mass haul diagram, because what is the most important expense that you look for in according to what you've learned so far in excavation and grades maybe is the haul distance. You know, that's your big deal. You know, you're going to need to know what that looks like in a diagram format, and you're going to know how to read that diagram format before you even start entering that into your software. You each will get, it's just like getting an ebook, and they're really cautious about this stuff. Each license, individual license, costs $4,000. And of course, that's not what you're going to be paying. And actually, that's not what we're going to be paying. They're letting us use this software so that when you graduate from here, you can say, I know how to use HCSS Heavy Bid, which is the most widely used cost software there is. You can tell them you use Trackware, so you're familiar with that, and or Earthworks. So there. Now, I want you to call me if you need a one-on-one. I want you to call me if you'd like me to go back, make another video. We can have a group of you can say, and you don't have to tell me how many. I'll set up a big blue button and go over this with you. It just feels like I just keep hammering the same thing in, but contempt prior to investigation, surest path to ignorance. That's an old saying. When you look at your module, look at everything, and sometimes I might forget something, but the video's been in there this whole week. You could have been reviewing it, and it's still there. It's basically what we've just done here, but maybe there's some more you can get from it. Maybe you can see it better. You can pause it, uh, upload it to YouTube to see it. I think you can do that to our videos I make. But anyway, this is it for today, or for now. Hope this helps. I see many of you haven't completed this 7th week, and it's probably due to this problem. Take your best shot, get this done. All you're doing is calculating volume. It's just the way you're having to come up with it is a little difficult. Okay? Call me if you need me. Thank you.